Nice.
Hey, we're live. This is Michael Finicaro on the AI Across the Product Lifecycle podcast. Really excited today. I haven't done any of these with a customer startups that were dedicated to specific markets. So it's really exciting to have Shahroz Khan, who's dedicated a CAD system to creating boats, and Roger, who's working completely differently on the health side, on the medical industry, Axial 3D and Compute Maritime. Welcome, guys.
Good to be here,
Thank you.
Mike.
Thank you, Thomas.
Why don't you guys go ahead and introduce yourselves to everybody? You wanna start, Shiraz?
Yeah. Hi, everyone. This is Shahroz. I'm a CEO of Compute Maritime. A bit about Compute Maritime. We're building generative tools for vessel design and simulations to help naval architects and shipyards and design offices to expedite their ship or what we call vessel development pipelines.
Awesome. And Roger, how about you?
So, Roger Johnston, I'm CEO of Axial 3D. We are a 3D medical imaging company, so we take any standard MRI, CT, X-ray, excuse me, ultrasound, any standard 2D medical image, and automatically turn it not only into 3D, but a rich digital understanding of that 3D. So we can automatically do things like measuring anatomy, or identifying anatomy, or classifying anatomy, or even doing things like surgical plans for your specific anatomy that are patient specific. So, but we'll get into that over the next time, Michael.
Sure we will.
It's really exciting. And before we dive into my questions, like why is it you guys dove so specifically into one market? Were you passionate about boats or about medicine, or did you just see a particular opportunity? How did you get this really narrow focus like that?
Roger,
Yeah,
go
let
ahead.
me take it. So, our founder, a guy called Dan Crawford, he actually came through medical training and biomedical engineering background. So, when he came up with the idea or the customer need, which was to deploy and be able to realize the benefits of 3D imaging at massive scale, in effect, to where any patient around the world can get access to have who can get a medical image, or a 2D medical image scan, can have access to 3D. That very much set the industry we were going to be focused on. And
awesome.
we're focused on one goal, which is for every patient around the world, whether first world or third world, to be able to have 3D as part of their care pathway.
Awesome. And how about you, Shiraz? Are you a
Yeah.
boat guy?
No, I'm not a boat guy, actually. Honestly, you would believe it. Although I always say that although I do have a PhD in marine engineering, but I would still not call myself a marine engineer. So I'm still a mechanical engineer, and I went on doing mechanical design. So when I was doing my master's in mechanical design, and a project came up related to CAD. So I did my master's at Istanbul Technical University. So, like the leisure industry, or what we call yacht industry, is
Up and
quite
down
big
the
there.
Bosphorus.
Exactly. So there was this project that was funded by Turkish Scientific Technological Research Council, something like that. And so the idea was, because when we are designing, let's say, like engineering systems, right? We always focus on, let's say, performance. And for the yacht industry in particular, it's not always about performance, but it's also about their semantics, right? Like how they look and feel. So for designers, like when optimizing, let's say, like boats or yachts, it's very easy to integrate numerically the performance criteria. But semantics being very subjective, you can't numerically integrate, right? Because they're very subjective criteria, and there's not a mathematical, let's say, formulation or definition to define someone's looks and feels of a certain yacht. So the project was about how we can integrate that semantics into also an optimization pipeline.
Awesome.
So that was the very first entry point for us, or for me, to both for AI and into maritime. So we went on actually building a whole standalone CAT system. We gathered loads of data about yachts in terms of images, and then we went on doing surveys with naval architect what they think about what this certain yacht represents. Is like looking luxury, is it charismatic, etc. And then we trained an AI model, a deep learning model on that one, and we integrated into our software, and of course that was part of the research activity, and actually we got a patent on the technology behind it. So that's what we were talking about 2015 actually.
That was a
Yeah,
good
so
segue
yeah,
into the
and
first
then
question, I think.
then the journey started to founding a company called Brain Labs, and in the Brain Labs we wanted to do generative design. But generative design has been there like for ages, right? But in that case, in previously, it was just based on the rules. So we will identify some handful of rules. We would hand code those rules to create some design variations. But in this case, in generative AI case, we have the data to create those design rules. That's where like the journey started, and we are now here in Compute Maritime developing
Awesome.
generative tools. Yeah.
Well, I like. Thanks for that background. That's really cool, and it segues very well into this first section of questions, which is back in 2022, we had this a tipping point, right, in terms of AI and LLMs, and suddenly everybody heard of AI, not just people that read science fiction or people that were academics. Were you guys? I mean, obviously your answer, Shiraz, is going to be pretty obvious, right? Because you're doing it already. But were you guys like super skeptical or super bullish back in November 2022 when OpenAI changed the world? What about you, Roger?
Yeah, so I think we were children of the time in that in 2016, when we were formed, we were born in the cloud, so there was no concept of us developing anything on a client server architecture or anything like that. And we were actually born in AI because when we started understanding the problems associated with turning 2D medical images into 3D, first of all, it takes a lot of compute power. So it had to
Of
be
course.
cloud, NVIDIA predicated. But actually, we needed the only way of doing it at scale that was fully automated was to train machine learning models that could produce, let's say, FDA quality outputs 100 or tending to 100% of the time. And to get that level of precision, the only route was AI. So we were very fortunate. Good luck, good timing. Born in the cloud, born in AI.
Nice.
No, that's a great example, and I would say a joke that I always tell that when I was working on this problem during my PhD actually, and someone would ask me like, "What you do? What research you're doing?" I was like, I don't know how to explain that. Like it's really hard. And then 2022, 2023, January, I defended. ChatGPT came. The like language models, what I would say, like language models came to the public domain.
Mhm.
So that was so easy to correlate, saying that, well, I'm doing something similar, but exactly for ships. So I think one thing that I always say that yes, the pivotal point we saw it in 2022 because um, the AI I would say like or the generative or the predictive models they came into public hand through the natural language processing, right?
Yeah,
So
they were
it's
democratized, basically, right? They were no longer
exactly.
academic exercises.
So that came through the language model. So when because we can correlate each other very easily through the language. So that's why like the public, I would say like concentration grew because the language model came out and they could see through language that language model have a lot of potential, and now these language models that like AI could also be used for other things. So what I always say, like even the very first model that was invented, was Boltzmann machine, was generative in nature. We stopped using generative models because we didn't have the capacity to do it.
Right.
Andrew Ng, which is a renowned figure in AI, his entire PhD thesis at Stanford was on generative models. So that the pivotal point actually happened in 2015 when Ian Goodfellow introduces GANs, and then the story continued in terms of images, and that's where like the 3D shapes and then the language came into being. So yeah,
That's
it's a
awesome.
quite exciting time. Yeah.
Sounds like I need to write some historical articles on that too, since I've written all the things on CAD and PDM. Um, uh, so I know you guys started before Cloud Code and anti gravity and well Cursor. If I go backwards in time, um, how has AI changed the way your developers are working on a daily basis? Obviously, it's hard to even imagine a programmer now not leveraging AI at all because you can just go so much faster. Um, what's it like at Compute Maritime for the developers? Are they in Cloud
um,
Code 24/7? Yeah,
we are using Claude for sure, like, but a lot of the technology that was built, I would say, like the hand coded by the programmer instead of like assistance having from the Claude. But now the interesting bit is that we have now agents, those who can understand the backend code that we wrote ourselves, right?
hmm,
And by understanding of that one, now we can implement multiple agents that work interactively with our programmers to help them
right,
expedite. And that's where an interesting thing that happened within the company, that we said we're not a company that is building a software, let's say like a UI. So we are a company that is building a technology, and we are
nice,
presenting that technology through APIs. But once you have APIs, you don't need to build, like, as a company, a UX, because the customers gonna design their own UX, and that serves two purposes. First, that software or the UX includes only the features that a specific design team or customers is interested in, right? And the second, the learning process become very simple because the UX is designed only for them. So that's why we say, like, we build backend technology in the form of AI. We stopped over development in terms of all from the UX point of view. We focus everything now in the APIs. And now we whenever a team comes up, we understand their problem, we see like which components of our array will be used, we plug in that, we see like if they have any existing technology that can be used, so we plug in all together, build a simple UX through cloud, and give it to them.
awesome. That
Hmm.
same with Axial
Yeah,
3D.
so I think if we look at our core system, the algorithm development, which we were born in, building for this process called segmentation, which turns 2D into 3D images, we then have further algorithms that increment or included that automatically identify the landmarks of the anatomy, that automatically create measurements for the anatomy, and even ultimately automatically create, could be a patient specific implant or some sort of patient specific device selection. That process, I guess the AI that we had in 2016 has incrementally improved, but that was already, I guess, the bleeding edge of certainly medical AI. Where we've seen the huge step change, if you imagine that those algorithms are wrapped in workflows, we have a platform that moves through the process from image capture through to whatever the surgical plan or device is at the end. That's just a standard web application or web platform application. All of the productivity gains that we've seen, where we used to have stack developers, and there are now a huge number of tools that have massively cut out that, make us much more productive. So let's take that to the base layer. I think the really interesting area here is, imagine that we're surfacing medical record or medical images that are used to be hard to understand, x-rays or CT scans or whatever. Now they're rich 3D images that you and I can understand, and there will be a automatic recognition that there's a clot, here's the size of the clot, here's the dimension of the clot. That just gets surfaced, the metadata just automatically comes up, because every doctor who maybe looks after stroke patients needs to know those informations. However, where it gets interesting then is whether it be in terms of the patient understanding of that, or whether it's providing broader information to the clinician team, is being able to actually go out to the various large language models, or models that are being created by whether it's Google or AWS or whoever, that actually could go, okay, for this type of patient condition, you can start getting either explanations for patients and what that means, what their choices are, all of that type of information that exists somewhere in trained models, or indeed in the broader global data sources. That is really exciting. So we can start building patient-specific clinical applications that are presenting to them not just here's the information, but truly what it means, and even what it means for them based on their patient record. So I think that opens up a whole lot of interesting space. Of course, one thing which we might come into, Michael, as we continue this discussion, all of this has to be done in a regulatory framework, because
Yeah, I was about to
that's where
say
this all
that
gets
you've got.
pretty fruity.
I was about to say that's kind of the maybe less of a challenge for Shiraz, but certainly for you is the fact that we're talking about probabilistic models, and you
Hmm.
need deterministic results, particularly in medicine. So, how is that a question of guardrails? Is it a question of just narrowing the scope of the AI in one particular domain to just something very very specific, just to driving it? Just give you enough lane to make a decision without
Yeah,
hallucinating.
so Michael, I'm so old that I was a COBOL developer in my first years. So I'm very used to structured software development. And I guess in many ways, even though we were born in AI, actually, as you say, we can't have dynamic, continually learning anatomical databases, because if we get 99% pixel accuracy, let's say on converting images from 2D to 3D, and then we get some rogue data and that dynamically alters the model, and suddenly what was FDA cleared no longer meets the bars. So what we have to do is in effect snapshot. Lucky I did all that COBOL programming. So we can take a version one of the database, we validate that, we do all the FDA tests or whichever regulator requirements are. We validate that, we publish that. So very much standard code releases. That then becomes the version one. We get our FDA clearances on that, and that works. The requirement is you don't put out an MVP, because you've got to get to clinical standard. But once you're at clinical standard, you're at clinical standard. You don't get many bonus points for going clinical plus standard, because it's not required. The clinical standard is what's required by medicine. However, what we can then do is go, okay, for whatever reasons, maybe we're adding some extra measurements or something, we want to do a version 2 of that algorithm. So what we do is do a retrain, make sure all the existing performance is the same or exceeded, that where we've added new bits, the performance meets the requirement, and then we republish that under as a new version. The difficulty in FDA worlds or in regulatory worlds is that historically meant a fundamentally new application to get. It's as if it's a new medical device. I saw a new and that's a 6 to 9 month process that costs six figures of investment. Where we've moved to, and we could maybe, I'll pause after this, we have got something that's called a PCCP clearance with the FDA. That means they have approved our version control, our workflow updates, or our algorithm updates, where as long as we stay within our ISO 1345 workflows and our development methodologies, they then go, okay, you're self-approved to self-approve the next algorithm version, which is awesome, because that means we can be like a
That's
normal
cool.
software company in the non-FDA world. We get the first clearance and then effect we self-clear and maintain all that justification and all that evidence that we've done all the testing, but we don't have to go back to the FDA again. So even though the regulators are slow and maybe not as fast as we would like, what they have done is actually be something that allows AI to be deployed in real world medicine, where you don't just have one static system that lasts for the next 10 years. It has to mature, and it has to be done in a way that's scalable.
Um, it makes me wonder for Shiraz, like you were saying, how you've got this agentic backplane. Do you have agents showing up for the Scrum meeting?
No. Yeah, I mean, the one thing, like coming to the point that this regulatory framework, even in I mean, like from over model or self, like over foundation model, because it's solely focusing on the geometry side of the things. and then creating that. I mean, like, there's two aspects of that. Like, first, like, where this data came from. Like, so the data came from a lot of, let's say, like, existing resources through the web, and also a lot of data that went into the synthetic data generation. And that's where, like, the large portion of our work went into. Like, almost took us 5 years to gather that data. So finally, into 2023, we were able to release the model. Another important aspect, like, is about this what we called class approval of the design. So the class approvals, you can consider them as a regulatory body that would approve your design from its, I mean, development to from its designing towards development towards operation. And that's where, like, a lot of bottlenecks are created from the classification point of view. So now we're also looking to see, because what we did, like, our model is not a language model, right? So what we say that because both the training data is 3D geometries, and the output you also get the 3D geometries, and the input that you give it to the model is your design specifications, and those design specifications can be in the form of, let's say, like a language, or it can be in the form of actual engineering constraints, the way that you define your engineering constraints. And once the designs are there, so a lot of question rises, well, these designs are new, right? So what the class or society gonna look at it, like how the approval process gonna look at for these designs. So we went on, like, we already solved a manufacturing layer also, because okay, well, if the design is very efficient, is it manufacturable or not? Right, this is the question. Another point, if we solve this manufacturing real, actually, we just solved it with a UK funded project from Innovate UK funded project, and now we're looking into this classification. Can we satisfy these rules or embed these rules early on the design, right? So then the design is that, like, is not only physics informed, manufacturing ready, it's also capable of being approved quickly through a class. So that aspect becomes very important, and then that creates this holistic model where everything what we believe, like, can happen at the preliminary design stage, right? So I'm not sure about the other fields of engineering, but what we say arguably say in shipping is that 90% of the environmental impact is logged at the preliminary design stage, right? So that stage becomes very, very important, where most of the way that we have trained over designers or naval architects, they don't focus that much on that stage. So the process is only you get a requirements from your customers, you go on exploring your existing database, you pick a design, and then you tweak this design a bit, and then you go on doing the detailed design and building the vessel right away. So I mean, and another point is that, well, this approach has been worked well, right? But now we have more advanced and efficient tool. We can actually think about now rethinking the way that we design the vessels, and then from there we can actually rethink how we are training our naval architects, right? So this is, like, I would say, like, we need to look at these problems holistically, with the help of AI and without the help of AI, however we want to look at it.
So in the current versions of Compute Maritime and Axial 3D, where is the AI sitting? Is it something that the user's seeing because there's a co-pilot and it's telling him what to do, or is it more just the plumbing underneath to make sure that the geometry is correct and the conclusions, the insights that it gains are correct? It sounds like it's probably the latter for both of you, but
Yeah, so
Roger.
to date, all of ours is in the plumbing. We have very little user interaction, in truth. So let's say that we are
Right, because they're just
looking at the
looking at the
result, and maybe
result
we
of
give them a
the
little bit of
analysis
the
on the
ability to
chart.
manipulate. Let's say a surgeon prefers a 3 centimeter long screw rather than a 2.7 centimeter long screw, and maybe they want to change the angle based on your bone density, Mike, something like that. I think going forward, where it gets interesting is some of these applications I was talking about, where the patient goes, in the context of their broader medical record, or in the context of the rest of the citizens around the world with their condition, with their same biometrics and their same whatever, the ability to actually go, here's a set of information, typical outcomes might be this, here's physio treatments you could have, and you could potentially query against that. And that would be much more of a Gemini-like UX for those sorts of applications.
Experience. Absolutely.
Yeah. For us, like it's really integrated. So as I said, like it's not just a co-pilot in a sense that where you're gonna say like write it down. Okay, I want to have a shape, and so this input is just a medium, right? The way that how we're gonna feed input to data. In our case, it's it's the design, right? It's a 3D geometry, right? It's a 3D geometry that is not just a variation of a random product. It's a 3D geometry of an at a very complex engineering structure, right? That gonna go sail in the real condition, will be exposed to various risks, right? So in our case, is the model trained on directly on the 3D data? So there's nothing, let's say like from the language aspect is there, okay, but we can do connection for the model that can render or the inputs in the form of language, but it's at the end it's the 3D design itself. Another thing to add here, that there's a lot of conversation, I would say, that AI for CAD and AI for design side of the things is happening. So what is happening at the back end actually, it's the LLMs who are converting the instructions into a G code, and that G code is rendered by a 3D CAD kernel, right? So if you look at it, so model has never seen a design itself, right? Well, you can represent a certain design or geometry in the form of text, but those intrinsic features, the context about the geometry is still hidden in this 3D representation. I think, Roger, that you would also agree here that, for example, in your case, right, there's very intrinsic elements of this geometry, right? From the anatomy point of view, from the geometric representation point of view, that are hidden within this 3D data, right? 3D scan, right? It cannot be rendered or converted into or embedded through the language. So yes, language can be a medium for your users to use your models, but the model has to see this 3D spectrum of the geometry, the kernel of the 3D, it has to see to understand the geometry well. So that's where I think industry now lagging, that everybody's saying like AI for design, AI for CAD, but that the CAD that hasn't been represented to the model itself. But in our case, that's what we did. The model, that's what we started, because the design has to be represented. Another point is that the model has to be informed intrinsically about what's the context of this geometry. It's not about just feeding a random data and then it's going to start creating random shapes, right? The shapes has to be, it should also satisfy the fundamentals of what defines a shape as a shape, right? So that context has to be embedded also, so that what makes a shape as a shape. So it should not spit out a log, right? So that this understanding, and then this understanding has to be given through to by creating also, I would say, like not just using off-the-shelf models, but also creating specific models for the specific problems. And that's what we did, and that's what I said, like the progression that we at the Compute were able to do, because our model was built around the specific
Shahroz,
problem.
I would say,
And
just to
then
pick
the
up on
language
some
has
of your
opened.
points there, I think the idea of, first of all, for the actual volume, the geometry of the 3D, understanding what, in our case, every pixel is inside that volume is really critical. Again, if we look back to an X-ray as an example, the question maybe a lab tech's answer, can you see where the trauma is or whatever it is? It's a very manual, can you look and visually see this? We want everything to be derived from, I understand in effect what every pixel in that 3D volume is. That's a ligament, that's a bone, that's soft tissue, whatever it happens to be. The second question is the context, because if I don't know that you want to see only skeletal structure, or it's a back pain patient and therefore I want to see their spine, I want to see their discs, I want to see nerves, without that context, then it's nothing. So we have to have that At that point,
Exactly.
maybe the ability for patients or surgeons or whatever to query starts getting really interesting. But it's that the first stage is exactly as you said, Shahroz.
Yeah.
My friend Michael Finning in the chat was asking, this is referring probably to the previous question. If you ever thought about using AI to configure the design software itself, like to have the AI configure the design software, not just the scaffolding or whatever, like no code but done by AI. Kind of interesting.
Yeah. So let me give you one first. The FDA, and I keep using them because they are sort of the gold standard of medical regulation.
Well,
Yeah,
yeah, and they're
they
your gatekeepers,
prescribe
right? So it's super
one
important.
method of training these large or these anatomical reference databases. Whilst there's lots of ways of doing this segmentation process, there's only one of those, maybe 8 or 9 different ways that they say you can get to medical grade. Therefore, actually looking at somewhere where the AI is used to you train the AI model and then it does its thing. I think the idea of using AI to actually create the design model, I don't quite know. I'm not clever enough, Michael, for that, but I think the barrier is likely to be we would need to get it to where the FDA trusted that. Uh, um,
Yeah, exactly. Yeah, I'm not sure that we get back to that
Amen.
probabilism versus determinism problem, right?
Exactly.
Um, you anything to add, Shiraz?
No, I fully agree. I think like yeah, that's I mean like, you can do that's like AI to build AI. I mean, but that the context then when I say again then is lost again,
Well, that's
right?
sort of what we're doing with OpenClaw, which is a bit crazy, right? But
Yeah.
but we're not talking about Facebook. We're talking
Yeah,
about boats
yeah.
and
That's another
bones,
story. I
right?
was like, we need another podcast for that then.
Um, well, before I move on to the last question in this section, I wanted to ask about, well, just some advice, because I did look at the demographics. I do have younger people watching the podcast, and I think a lot of people, because we're talking about these changes with AI. I suppose that even with AI, an engineer building a boat or someone working for Axial or a doctor still has to have a fundamental knowledge of what is anatomy, what is marine engineering. So what are the kinds of things that the younger generations, the people that are leaving university now and are very, very concerned that there won't be a job there because of AI, what do they need to focus on to get their chances better and work for an awesome startup like Compute Maritime or Axial 3D instead of going to some boring
Yeah,
corporate
so
job?
I think our world, we aren't a company that has hundreds of software developers. What we need is, and we recognize in what AI can offer, we are scratching at the surface, and we are just one little representation of where the medical diagnostic imaging market is at. We are at like level one, and there's 10 levels ahead of us over the next 10 years. So the opportunities, whether it be for graduates or research or whatever, we're at the start of a journey. And actually, a lot of this isn't about being able to write the code or whatever. It's being able to envisage, validate, build, da da da. That whole innovation cycle, we're just starting. Imagine our world started with, for the last 50 years, take a photograph, take a photograph, take a photograph. Now we're going, let's turn that photograph into 3D and start interrogating it. But now we're going to be able to automatically create diagnostics, automatically create recommended treatments, automatically produce whatever else. Change your lifestyle, change your diet, inform your relatives, inform your lawyer, whatever that. All of these things, there's just so much potential. So I think that's on one hand. I think if I look at then on our customer side, what this opens up is massive opportunities in our healthcare systems for solving the fundamental problem that virtually every healthcare system in the world, we all get older, fatter, sicker. That's where we're all going. We live longer. The cost of healthcare grows incrementally every year, compound 7%. There's no economy in the world is growing their healthcare budget, whether that's privately funded, publicly funded, or a blend at 7% compound. So if you're in a lot of the private economy, privately funded or majority privately funded economies like the US, we all hear the stories about healthcare is unaffordable. In other maybe government funded healthcare systems, we're in danger of moving to where we only provide the healthcare we can afford to provide as opposed to what our citizens need. What we've actually got to do is, with the same resources, be dramatically more productive. And that's what AI, not
Right.
by itself, but actually with people who understand how to build it in safely into these ecosystems, can deliver. So I would turn it away from, there will still, in my industry, whether it be from a provider point of view, a software or technology provider point of view, or the on the actual service delivery, the healthcare side, I'm sure there'll be different needs in different places. I don't see a fundamental reduction in staffing. I think what we've got is we've a combined obligation to deliver a lot more healthcare based on the resources we have, and that's the opportunity. So I think for any young person, if you have a medical bent or an AI bent or a combination of the two, this is an awesome industry to be going into.
And Shahroz, you would say the
Yeah.
same thing for boats?
Um, I will answer this question in two folds. First, generically, and then secondly, more related to the company itself. And I would start with the first one, saying that whenever there is a technological shift, right? Yes, one sector loses an opportunity, but a new opportunities grows, right? So let's go back and look at the era when everything used to happen by 2D drawings, not in only in, let's say, like in naval architect, marine engineering, but also in aerospace and in automotive, whatever engineering direction. Everything used to happen. Then the CAD came, right? The CAD came, I'm pretty sure a lot of draftsmen, they lost their job, but a completely new field opened, right? Next, we went on towards building simulation tools, right? So instead of conducting physical prototypes, we went on doing validating everything digitally. And that's where a new set of opportunities came. So when we went on digitally, that means different opportunities from different sectors came. Then there was engineers actually running code to build CFD tools, software engineers learning the maths behind CFD and the physics to help build those CFD tools. So this is one direction. And now I also believe, so now coming towards this programming point of things, and I think yes, a lot of companies gonna use, let's say, agents and AI to write code, but then we certainly gonna see an era where there will be a new way of coding that would be specifically designed for LLMs to understand better the context of the code, right? So the way that we have built C++, the way we have built Python, the way we built have any programming language was built for the human ease. But now the backend, whatever happening processing is in terms of ones and zeros is completely different, right? So we built for humans. Now there will be a completely different spectrum of code writing, because code writing is to give instructions to the computer, right? So we will have a completely different way of writing code, and that will be better understandable by LLMs. So a new way of writing codes will gonna emerge. So that's how the programmers gonna adopt to that. Academia gonna adopt to that to train the next generation of software programmers. So having a conversation that they're gonna left alone, I think this is not the case. Yes, there will be a ripple effect where some gonna see immediate effect, but there's a new set of opportunities gonna emerge. So now coming back to the computer maritime, that's why we focus a lot that what we call is, it's on the base of this human AI interaction. For our tool, for NeuroShipper that we had developed, at the end is the user, it's the naval architect who is the sole decision maker, who is driving the tool toward a certain direction. Yes, it is helping them to expedite their process, they're helping them to expedite the line. At the end, the final judgment will be based from the user. So that fundamental aspect of having a naval architect in your team will gonna stay there. So for another example is that although we in a company we're using a lot, let's say Claude and other softwares, but that doesn't mean that we're not gonna have any programmer in our team, right?
Okay.
right? So that's what I'm saying. We will still need someone to understand the logic, right? The way that we code. It's the logic will still need to be there. Yes, until we achieve a AGI, and then we will have somebody and just don't care about the human context. But then to create that, I would say generic models, then we would need more data. So the where that data come to train those type of models. So I think there's still a long way ahead to see that. But I'm saying that while we're moving that, there's new more opportunities going to emerge. The only thing I can say to the younger generation is that always be open to learn new things. That's
Absolutely.
the very important thing. Always be open to the new things. Just watch a YouTube video how to implement whatever field you're from. Just watch a video how to implement a cloud agent. That's it.
Are you guys both as bullish as you were at the beginning and now in 2026 after 4 years?
Yeah, absolutely. I think we there's both carrot and stick in our industry here. I think that the genuine enthusiasm for what's possible, and we're now starting to see. I think again, just the necessity or of behaviour of regulators in our industry. They're a pretty conservative bunch, so the healthcare industry in the broad tends to be a late majority, probably adopter. But we're now there. Now, what the big focus is: where can we get the big returns? Where is it safe? Where can we get real scale outcomes? I think the stick side is we've no choice because otherwise we don't have enough capacity in our healthcare system, or it's unaffordable. So
Exactly.
and that's a very powerful driver as well as the carrots.
What about you, Shahroz? You obviously
I
very
would,
bullish.
yeah, I would fully agree with Roger on that too. Like, yes, I mean, I think like what I said, I used to think like maritime industry is very conservative compared to other field of engineering, either is aerospace and automotive. But whenever I talk to someone, even from let's say automotive, they say like, oh, well, automotive is very conservative. And I was at an event in UK. I don't want to name the event, but I was at an event and I started talking to the potential customers, and they was like, they haven't started using CFD in their teams. So they're still using empirical methods. And they
Oh
were
my
like,
gosh.
how do you expect me to use such an advanced tool? Like, I am still not using, I'm still based on those empirical methods that were developed in 1950s.
Hmm.
I was like, what? But at the end, there were then the customers, those who were very interested. Those who
Right.
were very interested, those who were the ones, those who actually wanted to push the domain. So I think nowadays, like as the time process, so they're gonna be like this balance where people will try to understand, but of course, like some would be still like, okay, well, let's see, what happens. So I think the time will tell, but opportunities, as Roger said, is tremendous. Every day we're opening up a new, I would say, interesting idea from the team. Well, you know what? We haven't explored that. We could actually use our technology in that direction too. Well, you know what? We could train another model on the top of that, and then actually could solve also this problem too. So I think like this horizon of possibilities is very exciting things that what we can do with it.
That's a good segue into the next and last section of the talk, which is more on digital maturity. In both your fields, I think they're pretty notoriously poor in terms of digital maturity. In discrete manufacturing, where I'm mostly focused, I think of a scale of 1 to 5. One is Excel and email, which is pretty much the state of the art for a lot of people, and then 5 would be a fully autonomous digital twins, right? You do this an X-ray, and boom, you already know exactly what's wrong with the guy, and here's the treatment. And in fact, the drugs are popping out of the wall. Here you go, take this and go home. We're not there yet. We're kind of far. And I'm wondering, where do you, if on a scale of 1 to 5, where do you think we sit now in the medical
Yeah, so
industry and the
I think we're at a very clear point in healthcare. I think we are a 1, 2, 3, 4, and 5. I think it's a remarkable industry. So I'll give you the ones. So in large parts of the world, the way that orders are placed, it uses this technology that some of the folks watching this will know. It's called fax. So the, it is still, and please, if you don't know what it is, look it up. Um,
You
It,
saw that episode of the pit
it's
where the
bizarre. It
electricity
is
goes down in the
absolutely
ER
still at the
room,
core of
and they
many of the big healthcare systems. It is staggering. In terms
fax
of
machines. Yeah.
transferring medical images, let's say from one provider to a medical device company or something, the predominant standard, it's much more modern to be fair. It's called a CD. Um, and so these medical device companies have teams in rooms who receive CDs and then stick it onto the network. No, and but they've learned about this thing called the interweb, and they're moving that way. So they're going to move up to a two quite soon. At the other end, we see lots of instances of five where the technology is remarkable, and whether that's the software or the robotics or whatever. The challenge then, if I go, so we've got those two extremes, but in healthcare, having pilot projects or showcase projects or whatever it happens to be, where only those in Beverly Hills get to try it out, or only those who can afford massive amounts of money. That's not healthcare. That's proving what's possible. What we've got to do is see where healthcare is for the mainstream, for all of us who, whether we've got our own medical insurance or our healthcare is publicly funded, doesn't matter. For the 99% of it, where are we? And I think unfortunately healthcare is probably at best a three. Probably depends on which country. We're moving towards actually having a standard
Yeah.
medical record. So if you live in Bath and move to Bristol, the new GP can still maybe see your medical history, and we're even moving in the UK to where you can see your own medical record, which is obviously a huge step forward. But not being so cynical, I think we've got to find a way of adopting technology faster. I don't think healthcare ever gets to a five in the broad adoption.
Okay.
I think we'll always be a laggard because of this over need for regulators, as we say in Ireland, to be sure to be sure. So we've got to have always err on the side of caution on deployment of new medical devices.
How about in the maritime industry?
I would say like it's more or less a similar story. There's
Mm.
nothing much different. I mean, like I would just one thing to add on. Let's say like an example I would give like when. So I was talking earlier about this class approvals, right? For any vessel or any boat, any yacht that is built, it has to be class validated. It has to satisfy all the certain. The design has to satisfy all the certain set of class rules and stuff. So whatever happens, so when a design team designs as like a ship, and then gonna convert that ship into 2D drawings. So they're gonna submit to the class, and the class gonna use those 2D drawings to reconstruct the 3D geometry to see to further validate. So I mean, so so we're still based in this 2D world, right?
Yeah.
And another example that I just gave you, like a lot of people are still not, they're still based in empirical methods. CFD is like for any design team building any sort and shape of technology, finite element analysis, CFD, like any physical analysis, any digitally driven physical analysis is a must, right, to
Absolutely.
drive. And then having these low level empirical methods which are not accurate at all, they were built years ago, and new designs, another this raises another example that the innovation is not happening, right? If we're still validating over systems through a technology that was built years and years ago, that means the innovation in terms of design is not happening. It's still creating a lot of bottleneck. So this is exactly the similar story within the maritime too. Maritime covers more than 90% of our global trade. Anything that you see around the laptop that I'm having this conversation, the phone, the everything is comes through a ship, right? And at any given moment, there are more than 100,000 commercial vessels. It's an astonishingly big number. The only problem is the general public not get to see that number, like aviation, like automotive.
Mm.
So and that's the reason that this industry tend to be to be doing what they started doing like 50, 60 years or 100 years ago. And
Right.
now they started to become one of the most polluting company. And if shipping was a country, its environmental impact would be similar to Germany. So
Okay.
you see, like, there's a lot of factors that has to be taken into account. But this industry is so conservative, still based on this 100 years ago of techniques and approaches and the way of doing things. It's still very hard to break in through. But but now the regulatory bodies like IMO, International Maritime Organization, and EU has started to implement strict regulation, and those regulations are driven by financial penalties. So, and that's where all of the sudden industry started to shake up. Well, you know what? If we don't do something, then we're going to lose in millions. And I think that's a good driver. Not sure like how the severity. I don't agree with that, but it's a good driver to at least force the stakeholders to look for better solutions, and the search of these better solutions is driving the industry towards more modernism, I would say.
So speaking of better solutions, then I'd like to end, well, almost end on a question, which is my thesis is that using bleeding edge technology like Compute Maritime, like Axo 3D, is a better on ramp. Is really a much more effective way of moving your digital maturity towards the right, towards a 304 of a 5, than the old fart, traditional legacy platforms, right? Have you seen that? Have you seen where a customer was relatively conservative and things weren't really moving, and then they implemented Compute Maritime, where they started using Axo 3D, and boom, there was this epiphany, like, holy cow, if I did things right, if I thought about data governance, if I thought about AI and doing things right and not doing it the old way, geez, I would get so much more benefit. It would be so much more better. The patience would be better. The boat. So have you ever seen that
Yeah, I would
with your
say
customers?
in
Is it really
two
a
ways.
big?
If I look
Go
at
ahead. Sorry.
the incumbents, the big gorillas, and healthcare is dominated by or has many big gorilla players, whether it be in medical imaging or medical device or whatever. They all are still in
Mm-hmm.
competitive markets, and therefore, certainly the leaders of those gorillas, where they're competitive categories, they are really full on trying to work out how they can use AI to fundamentally gain competitive advantage. And they realize that their industry is quite slow moving at times. So actually, if they move at a reasonably quick pace, they can get a lot of competitive advantage. However, I think the really interesting thing, and probably across many sectors, is where it historically has been really hard to break in and become a tier one player in some of these categories. The opportunity now, if you're born in not just AI, but the latest generation of AI, and that's not just in terms of how you build your offering, but in terms of how you envisage your business, how you build your go to market plan, how you segment the market, how you target your first customers, how you scale your business, how you do your marketing, how you do your sales, how you do your customer support. If you're born in that capability and that way of thinking, you can build product that's fundamentally reimagined. You can build a business model that's fundamental. You're not trying to fix a last decade business model or something like that, or in Shahroz's case, a last decade or a last century's business model. So I think I
I
absolutely
agree.
do see it with the
Century.
incumbents, but I think what we should all be really looking forward to and excited to is genuine companies we've never heard of before that in 5 years are leaders in these categories.
Absolutely.
Absolutely. I think I fully second with Roger, and what I'm finding it very interesting how I can correlate maritime industry with medical, and this is exactly the similar story. To your answer, Mike. Yes, the early on customers, we focus on the smaller um, design offices, design firms, those who are focusing on, let's say, like smaller boats, leisure yachts, and offshore industry. So because the risk is quite small, and these are the ones, those who are, let's say, like are more into their bubbles compared to those big ones, the big three, what we call it, which I'm going to come back to later. So yes. So then the problem is, one thing is that you have to do a lot of convincing to those companies that you can actually drive. And the time that takes to actually to bring them that level of confidence, that costs a lot of resources, for a smaller company like us, and the company that are still evolving to build this lot of technology, where still a lot of day-to-day activity is very R&D focused and R&D driven.
Right.
But once they have fine, so that's why we do a lot of case studies with our customers at the preliminary stage. But when they see the benefits, yes, and then they're gonna come back and ask you like, can you does that? Can you do that? Can you do that? That's another issue, that right? So when the students suddenly see like some benefits, then they start asking like, can you do this? Can you do this? I was like, well, hold on, hold on. We just show you the proven case, but this also help us to improve our product. And then when I was saying like we are focusing on the API and the building of technology, that's also relatively driven by their needs. That we're actually seeing, let's say, more and more features that we can drive to do this. And then coming towards this big giants, let's say Hyundai, Heavy Industries, Samsung Heavy Industries, Hanwha Ocean, and let's say a few other big shipyards and design firms in
Asia.
Japan and in Asia. So yes, they have the capacity to do that. But the real benefit we will see, like when these companies that we have never heard of, they will come and they will start being the market driver by using this technology, then we will see, I would say, the true benefit and the value that these tools that we're developing, or the Rogers company Excel 3D is developing, that is having some weight, and I would say, yeah, some weight to actually to bring something from those big giants, someone there. So there you see the value in it.
Well, thank you guys. That was a really cool discussion. I know. I was wondering about where we can see you guys the rest of the year. I know Shahroz, we're going to see you at Develop 3D Live and Threaded, which is going to be awesome and work. Where else can we see you guys,
Yeah,
Roger?
so
Where can we
probably
see?
in
Where
the
can people meet you
UK,
over the next couple of months?
most of the events I would go to are with our amazing partner AWS. So we're not that, I'm a big supporter of the other global cloud providers, but AWS, we're all in on them, and we're building our ecosystem and platforms and solutions, and I think they have a real understanding in this medical category of what it takes to build highly trusted applications. So probably some of the summits with them, and in the US we hang out a lot at the big orthopedic and cardiovascular and oncology shows. So, but always available online. Always available online.
So I've got to come to Dublin to see you then. Okay. Uh,
Likewise, we're going to all the big events. A lot of so our strategic partner is Siemens, who are actually the early validators, of our technology, and Siemens is one of the biggest, I would say, digital tool developer. So we go a lot with their events. I mean, like our office is in West London and Chiswick Business Park. Just send me an email. Just pop into our office. Happy to meet, and send me an email. Happy to meet online. From the events, we're gonna be in the CF Fam or DC
CD
Fam.
fam,
There's a
CD
CD
fam.
Fam that is
I'll see
happening.
you in
We're gonna be
Barcelona.
there.
I'll
Yes,
be
in the
there too.
Barcelona. Oh, okay, awesome. That's great. So we're also gonna be in the Singapore Maritime Week. So all the
Nice.
major, I would say, maritime events, we will be there.
Okay.
And also like in Develop 3D Live, I will be there and happy to meet
Yeah.
anyone from
So
there and
yeah,
then
here's the
answer any
shirt.
questions. Yes, slowly.
So yeah, go to threaded.live and you can sign up for the show in Warwick or for Miami on the April 13th. It's been a real pleasure having both of you, Roger and Shiraz. I've certainly learned
Pleasure.
about both the medical industry and the maritime industry. I really appreciate your time. Thanks to the audience. Thanks for your questions. And we'll see you tomorrow. I've got Intop and Neuroconcept, two really huge players and that are changing the way we think about design and simulation. So thanks, everybody.
Thank you.
Stop.